Welcome to the Innovators Insider Podcast. I'm the user group guy, Richard Doyle, and this episode, I got my co-host back. I got to say, it was not a fun experience having to do this thing by myself last time, Michael, and I'm really glad to see your face this morning.
I really missed you too, Richard.
Great. Yeah, I think we do a lot better when both of us are here, and we have some fun and we have a good show.
I love the last show, though. It was a really great show. Lots of great content, though.
I appreciate that. It was really helpful to have Aaron there because he knows the partners. He knows the people behind the partners. So it was a lot of help to me, and I really appreciate that. So thanks, Aaron. Another shout out for you. I appreciate that. So today's show, we're talking about all kinds of different stuff, really, but you can boil it down to, let's say, Industry 4.0, right? And somebody asked me, how would you describe Industry 4.0? And so I went out and I did a little searching. I did a little look at history, and I wanted to start with Industry 1.0 because that actually happened a few years ago, starting in 1760. It was a kind of a German thought, a German way of doing manufacturing. What it really involved was the mechanization. Steam power came along, water power came along, and things changed for the better. And then in the late 1800s to early 1900s, that's when we started having mass production. And probably everybody knows, Henry Ford was the guy that really brought mass production and assembly lines to the rest of the world. Electrical power was big at the time as well because no more steam and no more power. And then it was all the way up until the 1970s. We went to Industry 3.0. And that's, I guess most of us, or some of us that were there at the time, remember that as the digital revolution. We started coming up with automated ways of production, and computers were all of a sudden an indispensable tool. You had to have computers, and certainly robotics started to come around in the 70s. And here we are now, Industry 4.0 going on right now. And some of the things that entails are the smart factories and the autonomous systems. The Internet of Things, IoT, that's getting to be really important. Almost everything you touch these days, as far as a consumer product goes, has some sort of Internet or IoT connectivity to it. And then the big thing, artificial intelligence or machine learning. So we're in a really fascinating time. But even if you go back to the 1760s, I think all four stages of industry have been really fascinating. And I encourage people to take a look at some of the history. So we've got a great guest today, right, Michael? And somebody that you've worked with for a long time. You've been at Onshape for a long time, and you know these folks very well. So I'm going to turn it over to you and let you introduce our first guest.
Thanks, Richard. Yeah, I'm really excited to introduce Matt Bush, the Chief Operating Officer at Hirebotics. How you doing today, Matt?
Good. How are you doing, Michael?
Very, very good. You've been an Onshaper for a really long time. We appreciate all the nice things that you have to say to us, but you also tell us, hard truths and everything too along the way. So we really appreciate your feedback and candor, and Onshape is the way it is because of people like you. So thank you. So appreciate it.
You're welcome. Yeah, we've definitely appreciated the fact that you guys take what we're saying and and act on it. I was just telling a customer of ours yesterday, we were talking about CAD, and they're on an old version of a competitive product. We'll leave it at that. And
sure.
I was like, hey, you guys really should look at Onshape. And I was like, one of the great things is, like, every time we have a feature request, it just winds up in the software. And he was blown away because he can't get a CEO to let him upgrade to a newer version, so they're missing a lot of stuff.
Yeah,
I was like, that would never be the case. You're always on the latest, so we definitely appreciate it.
Awesome. And your products are really amazing, and I thought it would be great to share what you're doing with the community of people. I'm sure everybody knows about robotics, but the way you work with robotics, I find to be fascinating and really innovative. I think, robotic welding for hire. Like, how did that come to be?
Yeah, so in 2015, so many decades ago now, in Hirebotics time, Rob Goldie's co-founder and I, we decided there had to be a better way to do robotics or automation in factories. A lot of people really struggled to put in automation, especially smaller manufacturers. But one thing we knew that all manufacturers know how to do is hire people. So we're like, what if we could make a robot that people could hire, just like they hire a person? And so we set out and we built the first iteration of Hirebotics, which was, we primarily focused on machine tending, assembly tasks, very complex cells, full turnkey integrations. And our customers literally hired the robot to go do a job. We build them every week. We turned in a time card weekly based on data coming back from the robots. And so, and it was this confluence of the ease of use of cobots coming out with universal robots and how easy their robots were to work with. And not just from a software standpoint, but how easy they were to work with, because we could put one in the backseat of a car and take it to a customer. Like, we didn't have to have 3-phase power. We had single-phase power. We could literally pick it up and move it by hand easily. We didn't have to have large safety enclosures. And then we also looked at the cloud and everything that the cloud was bringing, and all these tools that were coming out around the ability to build your cloud infrastructure without really being a software developer, because neither one of us have a background in software development. And so we set out, we built the system. They were fully cloud connected. What that means is they were streaming a lot of data, Industry 4.0, Industrial Internet of Things. And we used that data for billing. We needed to know how much our customers were actually running these things. They were going to be all over the country. We had no way of being there to monitor them. And so we set out to build this cloud infrastructure. We found Onshape in the meantime. This was early 2015. Still in beta at the time, actually. Signed up with Onshape, got on, and started building cells in it. Fast forward a few years, and we got approached by Airgas, our division of Airgas, ReadyArc, and said, hey, there's this huge shortage of welders. We rent welding equipment. You rent robots. How about we make a welding robot? So we said, awesome, let's go do it. So we set out and built the first generation robotic welder that we did, called BotX, which is still available today through ReadyArc and Airgas. And with that, what you really got was this. We said, how do we make the user experience of using this system different than what traditional robots is? So traditionally, even with a cobot, you're on a teach pendant, you're writing code. And so the industry in general is having a hard time finding enough automation engineers to come put robots in. So it's like, why do you want to trade your I can't find welder problem for I can't find robot programmer problem? Because they're both having a problem.
So even back a few years ago, this was, starting to rear its head as an issue, is finding the right employees, people that are trained. Yeah. Okay.
Yeah. It's been the automation space and the welding, it's been a problem for a while. And so we set out and developed, the first cobot that you control through a smartphone. And it was a smartphone app that we developed that allowed you to very simply teach the cobot how to weld a part through a smartphone interaction. We did well with that. That launched in 2019 at FabTech in Chicago. Pandemic hit, obviously slowed us down a little bit, but we still deployed a lot of robots that year. And it enabled us to bring out other tools that we've now really taken advantage of, around the ability to virtually demonstrate the system to users. Really highlighted Onshape as we were developing still mechanical parts of the system, as we were changing designs and stuff, because now we're all working remote, but we're all able to get into the same model and work on the model, get in there, do design reviews on the model. So it really, for us, started to highlight the power of Onshape as a cloud tool, more so than when we were all sitting in office together. Because when we did a design review in the office, well, what did we do? We all gathered around one person's computer and put it on a projector and did design reviews. Now we're doing design reviews by, hey, everybody log into Onshape and just follow me.
Yeah.
Right. And we're gonna walk through the model and chat and stuff. And so last year we launched what we call Cobot Welder, which is our second generation welding product. Brand new app, brand new cloud infrastructure, more intuitive. We took everything that we learned from the first generation product and fixed everywhere people had issues. And the way we know where people had issues is because it's a cloud connected product. We can monitor how people are using the app and where they're getting stuck, what questions they're asking us, because it's got built-in support. Users go directly in the app and ask us questions about how to do something, or I'm having this issue, or whatever it is. And so we're able to really track and monitor what are all the conversations we're having over time, and how do we go resolve those problems. So we launched the last product last year, some new hardware configurations, but a lot more magic between how you interact with the hardware and the software. So when you're in the app, you're not actually talking directly to the robot. You're talking to a cloud server. The robot's talking to a cloud server, and then in the cloud, the two are being joined. But to be able to simply tell the app, like, hey, I want to do something, I want to teach a point, and then on the robot, click a button, and instantaneously that point drops into the app. I want to change what I'm doing in the app, so I can touch another button on the robot, and it will change what the app is set to. So I can bounce between air motion and welding, for instance. And, all that's for hardware interaction on the robot, but the app is changing its interaction as well.
Right.
So we have this very seamless hardware to software interaction going on. And it makes the experience for a lot of our users very magical the first time they touch it. They're like, this is just amazing that I can teach an entire part in a matter of minutes how to weld it. And I never had to touch the phone other than to start the program and hit save.
Mm-hmm.
Like, I did all of the teaching touching the robot. And that's very, very, very different than the experience most users have today with robotics, where they're on a teach pendant and everything they do is on that teach pendant. Even for a cobot, when they're using their hands to move the arm around, they're still having to pick up the teach pendant and type things in for the most part. And so it's been very magical how we've been able to pull all that stuff off.
Yeah, it seems magical to me. The last time I welded something, I was back in shop class in tech school, and just right there by hand. So this is really magical to me to hear that you can literally, from your mobile device in your hand, like program a robot like that. That seems incredible to me. And you're able to get so much data, so much, information, because it is hooked up, SaaS to the cloud. You're able to make it better. You're able to, learn a lot, I bet. From that information.
Yeah. I mean, we give all that data back to the users. And so they're able, through the app, and it's now also a web app, so you can be on your desktop, for instance, or your laptop. But they're able to go mine that data as well and create dashboards and charts and metrics for how they're actually using the system. So utilization rates, wire and gas consumption. So if you want to know how much wire and gas you're consuming every day, just chart it. Part production, cycle times, all of this data is just there. So I was at a customer yesterday, just about a system, doing some training. They actually have engineering interns in for the summer that just got there Monday. When they showed up, there was a box with a robot in it. They were told to put it all together, which everything is done online. So, I mean, you just click, there's a QR code on the box. You click the code, it takes you out to the instructions for how to build the thing. And so they get it all together. I show up yesterday. I'm doing some training with them. And I mean, no joke, we started training around 9:30 yesterday morning. We were done by 10 a.m. By 10:30, they were welding production parts.
Oh my.
And they were setting them up. I wasn't doing anything other than, just making sure they were doing it right and helping them with some of their weld settings. Because these are, they're 3 kids from engineering schools. 2 go to New Jersey, school in New Jersey, and the other's a school in Tennessee. So they're not welders. And they have another intern that has learned how to weld over the last few summers. Comes in and actually works with them on the weld side. But he's still not a welder. And so, I was able to help them understand some of the weld settings that they needed. And they were just blown away by how quickly they were able to teach parts. I think by lunch, we had taught our 3rd production part.
That's amazing.
And ran parts. And they look better than what they're getting today by hand. Cycle times were incredible. I mean, we were doing parts in, 12 seconds of welding. And these are small parts. And they're like, I can't weld it by hand in 12 seconds. Like, totally. I can't pick up the torch and get ready to weld.
I was just going to say, I wouldn't even be able to put my welding helmet on properly in that amount of time. Yeah.
Right. And so when they see that, because I was talking to the CEO, and he's like, oh, we got to be able to put all these parts on. I'm like, no, you probably don't. You probably only need to put 1 or 2 on the table. And once he saw what it was running, he's like, you're right. He goes, we were way overthinking how to make this thing productive. It's just productive. And I was like, well, that's the advantage of a robot, right? They're going to be very productive. I said, the advantage of our system is you're productive in teaching it. Instead of taking a day to teach a part, you can take 10 minutes.
Right.
We have customers that have traditional systems, and, they're blown away when they do time studies internally that, how much faster we teach a part, but the fact that the traditional robot to our robot, the cycle time really doesn't change. The robots actually weld the part in about the same amount of time, but they can be so much more productive as a robot programming team, because now instead of only getting maybe 1 part a day, I can get 10 parts a day.
Right.
Programmed and set up.
Wow.
Yeah, we're finding a similar analogy happening in the world of Onshape when you automate Onshape with feature script and things like that, and creating your own custom features for your business. You're able to, you're pairing hardware engineers with software kind of ways of thinking, and you're going to be able to instantly make your business more productive. We're seeing it in lots of places, but this is a really cool way of solving multiple problems with the workforce shortage, with more reliable and faster. And the setup is just instantaneous. I mean, that's incredible, to be able to do 3 jobs before lunch.
Yeah. And so, we did the same thing. So especially when we were doing full turnkey integration systems, we did a lot of feature scripts, right? So that we could drop certain features that we always had. We just dropped them into the model. So one of the ones that we did early on was dowel pins. We use a lot of dowel pins in automation because you've got to make sure things are located correctly. We just had a dowel pin tool. You clicked a datum and said, drop a dowel pin there. Oh, I want not just a dowel pin. I want a shunk, dowel pin, what they call a dowel pin ring. It actually takes a bolt through the center of the dowel pin. I want a shunk part number, da-da-da, and it dropped it in. Or I want a Festo part number, da-da-da, and it dropped it in. Made sure everything was toleranced correctly on the front side and back side. So we had slip fit, press fits, and or you could drop in ISO standard dowels or NC standard dowels and just drop them right in with all the proper clearances.
Right.
And so it really, just that one little feature, and it didn't take us that long to write it, but it was amazing how much that freed up our engineers to go think about other things in the design, because I no longer had to worry about, did I get the tolerancing right on that part? Or because we only bought one of something usually. So is it going to come in and be able to go together? I don't know. Oh Lord. And so that was something that we were able to take out of their minds of thinking about. We did the same thing with like tool flanges for the robot. We had a tool flange tool. Just drop it at the center point of where you want the tool flange, and boom, there's your tool flange.
So you have a button in Onshape. You hit the button, and it puts in the flange. You select where you want it, and it's done. You don't have to think about it.
Yeah, it puts all the right bolt patterns, the dowel pins, everything in correctly, so that I just want it to be centered here. Boom, done. And so there was just a lot of little tools like that you look at and you go, well, it only took 5 minutes to do it every time. Yeah, but we have every engineer trying to do 12 systems a year times however many engineers we have. Well, that's starting adding up to hours a year that we're saving.
Right.
Right.
Well, people probably expect, high throughput, when you're working on a consulting project with a client, right? They want your robots because they want to do things faster. So you have to also be prepared.
Well, and when we were doing the hire model, so when everything was being paid out by the hour, we didn't collect any money until the robot started working its job. So think about like a temp agency where you say, hey, I want to bring in this temp worker, but before I'll pay them, they have to be fully trained.
Right.
Your job, Mr. Temp Agency, is to fully train this employee before they come on site. And that's what we were having to do, was basically fully train the robot before we ever got the first paycheck. So the faster we could do that, and the more we could compress that time, the faster from contract signing to first paycheck. Right. And of course, we're paying costs all along the way. We've got, components we're buying, engineers we're paying, right? And engineers don't get, they get paid by the hour or paid a fixed fee. So the longer it takes them to complete something, the more we've paid that engineer for the design work. So everything we could do to cut minutes and hours out of a job, benefited us. So we did a lot of stuff around, we have very standard libraries in Onshape of, like, here's our sensor catalog. It's already in Onshape. You just go to the catalog. Everything is by vendor part number. I want this part. And those are the approved sensors that we have, or approved cables, or pneumatic systems. We already had pneumatic manifolds that were built, already assembled, ready to go. Drop them in your model, configured. When the configurator came out, it was a great tool because we were able to simplify a lot of what we were doing. So we already had pre-configured assemblies that we had an engineer with some free time that sat down and configured all these assemblies based on different ways you could put it together. And we would just drop it in, everything to try and save them a few minutes when we had a project.
That's great. Yeah, it's great. It sounds like you're comfortable with development and software a little bit, and a little bit of feature script. There's a little bit of an entry, but there's some courses now. We just put out a new course to help make it easier to get into feature script and creating your own custom features like you have. So we'll put a link to that course in the show notes. Because it is. Oh, go ahead, Matt.
Well, let's say one of the most awesome things when feature script came out that helped us get up to speed on it, because the courses back then were not that good,
right,
was I just went and looked at how did Onshape build a feature. It's all visible.
Right.
How'd they make the whole pattern? Oh, that's how they did it. Okay, I'll do it that way.
Yeah, it's a pretty good.
We just went and stole. Not stole. Stole's not.
That's why we put it there. It's
we
there.
Went and explored how the features were built in Onshape to begin with.
Yeah.
And said, how do we leverage what they're doing and understand how it works to really be able to drive this and make these features efficient. And one of our mechanical engineers who was studying, he had a little bit of a software background in college. He actually picked it up and was the one running with it. He's the one that wound up writing most of the feature scripts that we had.
Interesting. Okay, so you paired mechanical guy with somebody who's got some good programming and it worked. That's great.
Yeah.
So how about the other side of the business for you? Like, obviously you're doing coding, software development to program this app, to work with the robot. How does that work at your company? Like, between the hardware team, the software teams?
So we really have three teams within Hirebotics. We've got what you could call infrastructure software. So that's our app, our cloud infrastructure, the servers, all of how the user will interact with the product from a software standpoint. We then have our hardware development team that does all of the actual hardware design in Onshape, whether it's, the robot and actually getting it into the cell, the different, user interface components, the mechanical, physical user interface components. And then we have a robotics software team. And so the way that all works together is the robotics software team and hardware team work pretty closely because we need certain features in the hardware to be able to interact with the program. We need to understand what the hardware is doing so we can write the right kinematics and stuff around it. So those two teams work very closely together. We actually have a lot of overlap between the two teams as far as personnel even. And then the other overlap is between our robotic software and our infrastructure software teams. And so a lot of that, because we're trying to move very quickly. So for instance, when we brought out the Gen 2 product last year, from when we launched the development effort until we froze the code for final debug and go live was about 6 weeks. So we've built a lot of our own tooling in-house for the robot side so that we can run the code without actually running it on a robot. We have the ability to completely unit test it, completely end-to-end, do end-to-end testing, so we can actually build what we call a flow, which is the data structure that's going to make the robot program work. We can pre-build a flow and actually run the program against that fake data. And so what we do is between the two teams is we'll sit down and say, hey, here's an API layer between the two. This is how we're going to communicate. The data that I'm expecting to receive from the app will have the following structure, the following keywords, this type of data. And what do you need from us as return values, for all the data that you have to show in the app. So one of the things that's really cool about the app is as you're in it, you can watch the program execute on your phone. So even though I'm sitting here at my house in Middle Tennessee, I could be logged onto our sales guy's robot in South Carolina, or not logged onto the robot, I could just go into it in my app, and he could press play on his robot, and I could actually watch his program execute in my phone. Right. Well, to do that, that means the robot's sending data back to the cloud. And so they'll tell us what they need from an API, what data they need. And then the two of us basically go off and develop independent of each other. I know what our promise to receive from you is. You know what our promise to give to you is. So we go off and write robot code. They go off and write app. And then we come together and we start, all right, we're going to start testing the app against the actual robot code. telling you what we like about interactions, what we don't like about interactions. Looking more at the UI UX, knowing that at the end of the day, the data on the back end is already there because we have that promise to deliver between the two teams. And so then it's just a matter of they're working on how we actually interact with the app, and we're working on how the robot consumes that data and how you interact with the robot. So it was really cool because the first few weeks that we were running even code on the robot, we had no real data. We would literally go put a file on the robot and go execute against that file. And it was a file that we hand typed out. But we can make it move. And so by doing that, it really allows us to move very quickly in development because neither one's waiting on the other. We're able to move very fast between the two teams. But we also do the same thing with hardware. When we're doing the hardware, we have certain interfaces. We know the robot has two interfaces. It's got a base flange and a tool flange. It's the same promise, right, as software. The robot promises to deliver a flange that looks like this and a flange that looks like this, and we're going to mate to them. So we know, and the table looks like this. So we need an adapter that mates this promise to this promise. Done. We need the following buttons because we need the following physical interaction between the robot. We need a emergency stop. We need a play button. We need a stop button. We need a safety input, which is welder on or off. And we need we're going to have this operator input button where the robot can turn on a light and the operator can press the button and the robot will go back to work. So we start to define what these interfaces look like. At the end of the day, I don't care what the physical part looks like. I just care about what the interface is, because if I know I'm going to get the following inputs and outputs from the hardware, the physical hardware, well, I now know how to go work with that in the software.
Yeah.
And so now we can turn the designers loose to say, hey, go design me a mechanical system to the best of your ability that's cost effective, good aesthetics, whatever it is. Just make sure that you give me the following interfaces. And we'll know from a hardware or software standpoint that we're able to interact with those.
Yeah, you'll start with a functional specification, and then it'll kind of parallel off into each of the different phases of mechanical and software. Yeah, that makes total sense. And then build it based on the functional specification.
Yeah. And because we are such a software-driven company, so we really look at ourselves as a software company before we do as a hardware company. Because no matter what we're doing, whether it's the robot, the app, right, we're writing a lot of software. I have more guys in the company that are software backgrounds than we do hardware backgrounds by a significant number. And so one of the things that we love about Onshape is the fact that the PDM function is basically like Git, like we use for software. And so it's, just like we do a pull request on software to interact, to ingest something into the main branch of our software. We do a release in Onshape off some branch to ingest it back into the main branch of the hardware. And so for us, the workflows are so similar that it makes us all have a similar language within the company. So we're talking about releases, we're talking about pull requests, we're talking about branching and main branch, feature branch. Whether we're talking hardware or software, we all have a shared language,
right?
Which is definitely very different than any other software, CAD software I've ever been on.
Yeah, you're able to use these agile methodologies, with Scrum and product owners and branches. It's totally awesome to hear that, and more companies are like you, where there's a lot of software, to their products. So we're hearing what you're saying a lot now. So it's really starting to happen as the electromechanical product design teams are working more together. They are understanding the benefits of an Onshape style version management system, totally inspired by Git. Totally. I mean, we really did, want it to be a nice visual approach to what they do for branching off and trying out different ideas and, features. It's I think we'll be putting out some content soon on this as well to kind of show really, step by step how to use Onshape in this type of workflow. So, but people naturally just do it in your situation.
Yeah.
Right. So it's really about teaching the people who are used to the waterfall type approaches and stuff. So cool.
Yeah. Yeah. And I mean, the more Industry 4.0 really rolls out, the more IoT rolls out, the more interaction we're going to see with hardware and software teams.
Absolutely.
We've got a mechanical engineer on staff who is also a software engineer. So he can design mechanical products, and he can also write the software that runs them.
Great.
It's the best of both worlds. I'm a mechanical engineer by background. I'm not a software guy. I have learned through absolute need to write software, and now spend way more of my time in software than I do hardware.
Mm-hmm.
I'll jump into Onshape every once in a while and do something. But it's rare that I'm in Onshape anymore. I'm more in software because that's the bigger part of our company.
Right.
Because Onshape's made the hardware, it's made it easy enough that a 1 or 2 hardware guys can handle all the hardware design that we have at this point.
Richard, what are your thoughts on robotic welding?
My head's just spinning here after hearing all of this stuff. I mean, we're talking Industry 4.0, but to me, it seems a little bit more like Industry 4.5, that you guys are actually exceeding 4.0. I don't know. I mean, I don't get the joy of interacting with robots very much, especially over the last 20 years because I've been, working community kind of thing. I do miss the manufacturing areas. I miss seeing how things work. I miss designing things. So for me, I'm just here to sit and listen and just be awed by what I'm hearing here.
Yeah, it really is incredible. It is. I like the way you use the words, Matt. Magical. I like the way I like this promise concept of how you establish promises between the different interfaces and relationships of both the hardware and the software, and how you explain that too. That's something I learned today that I'm gonna try to incorporate myself into how I think about things. It's really, this is a really great conversation. Totally. I think, I think we're all going to learn something here as listeners. So really want to thank you, Matt, for joining us today on the show. Next up, we have Richard with some tech tips. Yeah, you're welcome to join and comment on any of the tech tips, Matt, or you can hang. I think we get about 10 minutes or so.
I'll hang around. Curious to hear the tech tips.
Awesome.
So, okay, well, you may regret your decision after I'm finished here. So we had a little trouble. We've been doing these for the last few episodes where we get the Onshape Tuesday tech tip, and we get the person that writes that tech tip on to show, talk about it on the show. Well, we had a little trouble scheduling this week. So
it's for a good reason, though. She's at the Make 48 competition, which is an excellent competition sponsored, where they're making complete products in 48 hours. If you haven't seen the show, it's an incredible show. You got to watch it. But sorry for interrupting.
And certainly she made the right choice on which event to attend today. So it kind of fell, it kind of fell on the rookie to do our tech tips this week. And so what did I do? Of course, I went back and I looked at some of the old tech tips, and I thought, well, I'll steal those, and but I won't take credit for them. I'm going to go ahead and give the credit where credit is due. So the first one I want to talk about is creating custom colors, right? So we all know we can add appearances, colors to our parts. You can do it through the menu. You can do it through the mixer, however you want to end up doing that. But sometimes you want a specific color somewhere. And, like I say, we can do that on the whole part, but we can also edit the appearance of a face. And let's go ahead and add an appearance to this face. You can actually use your own RGB values for this. So I happen to know that my favorite color blue is 00255. And you can see that it's added that color to the face. The cool thing here is you can actually add that to your custom color, so you don't have to type that in again.
And that'll follow you around no matter which computer you sign into, which you can do this in some other CAD programs, but you're going to have to customize your experience for every computer you sign into.
Exactly. So let's do that one more time with the RGB values. Here's a color that I think most engineers and designers can understand. And this one is...
very nice.
Well, they call that khaki. Let's do one more because we can actually do something a little bit different.
I think that's the color of my pants right now, Richard.
I wouldn't be surprised, Michael. I assume that hundreds, or if we have thousands of people listening to this today, that many of them are wearing khakis. The other way to do that is through a hexadecimal code. And so instead of the RGB values, you can go ahead and type in your own hexadecimal code. I just happen to know that FFFACD is the color for lemon chiffon.
Excellent.
And that's how you change your colors and add your custom colors.
Transparency is also supported. So I use this all the time to, like,
Yep.
If a part is like, made of glass or plastic or whatever, you can add transparent colors. In this box too, that tessellation quality thing is one of the unsung heroes, especially if you're dealing with complex products.
Yes. Curves
curves
you have
and
a
arcs big round object. You can crank up or down the tessellation quality. You can even configure these things, like configuring the tessellation quality of your part. Instead of defeaturing a part, you can configure the tessellation quality and make it look, make a circle look like a hex. But it's totally a way of defeaturing stuff a little bit as well. And but I'm not going to keep going on this because you got two more tech
because
tips.
we could talk all day. Yep, I have two more. So let's talk about snap mode. I've said it on the show before. I say it in most user group meetings, and I'll tell anybody that's listening. Mate connectors are absolutely brilliant. One of my favorite things about Onshape. And we know that we can go up here. We can do a fasten mate to get our bolts where we want them, right? And it picks up. Come on. Right. So that's your fasten mate, right?
Yeah.
But there's also something here called snap mode. And when you invoke snap mode, all I have to do then is grab an implicit mate connector and drag it over, and it will pop into place. Yeah. And of course, I have the A key to go back and forth.
Mm-hmm.
So that's what snap mode is, and I suspect that a lot of folks haven't tried that one out yet.
I'm guilty of not having that button turned on where I could really take advantage of that, especially if you actually hit the insert menu there, Richard, and insert like a part, just any part, it'll actually work even now. So if you had a mate connector in that part predefined, it would actually kind of jump right into that snap mode instantly. Yep.
Just make sure you have those mate connectors set up first. Yeah. So I'm going to close this out for just a second here real quick because I want you to see something. So this is the podcast tech tips file or document that I've been using. And you can notice this is the thumbnail image for it. Well, if you want to change that thumbnail, it's really, really easy. Just right click on the tab that you want to use, select as document thumbnail. And now when I close my document, you can see that I have a new thumbnail. Thumb? Yes, that is my thumb.
Did you scan your thumb, Richard?
I did not. I did a Google search and pulled that baby right off the internet.
That's awesome.
So those are my tech tips for today. I hope everybody learned a little bit of something on that. I'm still a newbie when it comes to Onshape. Someday maybe I'll have my own tech tips, but for now I have to go out and steal them. Just wanted to give credit to Cody Armstrong. He wrote that tech tip on the custom colors back in October of 2018. Snap mode was done by Jenny Johnson. That was earlier this year, January 11th of 2022. And changing a document thumbnail, that's our good friend Matt Rohr. And he did that tech tip back in December of 2021. And you know that you can always go to onshape.com, go to resources, select tech tips, and you'll get all of the tech tips that have been done over the years by our fantastic technical services engineers and some other folks at Onshape. So
yeah, we've had Matt on, but we got to get Jenny and Cody on. I mean, Cody, the voice of Onshape, if you will. Yeah. From the very early days, that's how I thought of Cody, and Cody's just a great guy. He's my boss, full disclosure. So, but
I can say as an independent third party, Cody's a great guy.
Yeah,
absolutely.
He really is. And then Jenny, I worked with Jenny for years, back in the old SolidWorks days. So it's awesome having Jenny part of the team. Great engineer, part of many really cool engineering projects over the years, and
a dynamic speaker too.
Very dynamic speaker. Excellent person overall. So really, we'll have to have her on. She has a lot of good stories.
Yeah. Well, that's a pretty good show, huh?
Yeah, it was a great show. Thanks, Matt, so much for joining us. It's great to hang out with you, and got to get down to mid Tennessee sometime. It's been too long.
Yeah, come see us anytime you want to come play with a robot, Richard. Let me know.
You bet. You bet.
I've got one in my lab that you can play with.
Outstanding. So the next show, Michael, I think we're looking at doing something along the lines of Onshape in education, but we're still working out the guest list on that. So hopefully people will join in 2 weeks. For you that have watched or listened today, please subscribe to our podcast so you'll always know when the latest episode is out. And if you liked what you saw, we'd sure appreciate a like or two. We really appreciate that. Michael, I am so glad that you are back this week, and I look forward to you not going on vacation anymore.
All right, I'll do my best.
Great.
All right,
and
see you all.
Take care, everybody.
Thank you. Yep. Bye.